Given A is a square matrix satisfying the equation A square minus 5A plus 7 times identity matrix of the same order as A, which is equal to 0 matrix, that's null matrix, same order, then A inverse is equal to. So to find A inverse, and let us assume that inverse exists and determinant of A is not equal to 0. So in that case, A square is equal to 5A minus 7 times I, and pre-multiply A inverse on both the sides. So we can write A inverse into A square, we can write A into A, which is equal to A inverse of 5A minus A inverse of 7I. A inverse into A is equal to, we can write 5 times A inverse into A minus 7 times A inverse into I. We know that A inverse into A is equal to identity matrix. So IA is equal to 5 times of I minus 7 times of A inverse into any identity matrix, or A into identity matrix is equal to A. So we can write A inverse into I will be A inverse. So I into A is again A. So we can write A is equal to 5 times A minus 7 times A inverse, or 7 times A inverse is equal to 5I minus A. So A inverse is equal to 5 times I minus A divided by 7. So that is 1 by 7 times 5 times I minus A, which is our option 1. Given A is a square matrix of order 3 and determinant of A is equal to 3, and we need to find the determinant of 3 times A inverse. We know that determinant of Ka, where K is some scalar, some real number, we can write K to the power of n into determinant of A, where n is the order of the matrix A. So here order of the matrix is 3 by 3, so that is 3. So we can write 3 to the power of 3 into determinant of A inverse. And also determinant of A inverse, which is equal to 1 upon determinant of A. So 3 power 3, 27 into 1 upon determinant of A, which is equal to 27 into, and determinant of A value is 3. So 1 by 3, which is equal to 9. So therefore 9 is the answer, which is option 4. Given a matrix B is equal to a 2 by 2 matrix 1, 3, 1 alpha, and which is the adjoint of a matrix A, and determinant of A is equal to 2, and we know that determinant of a matrix A will be same as the determinant of adjoint of a matrix, that is determinant of A is equal to determinant of B, because adjoint of matrix A is B. So data value is 2, so we can have 2 is equal to determinant of this matrix 1, 3, 1 alpha, So we can write alpha minus 3 is equal to 2. So alpha is equal to 5. So the value of alpha can be taken as 5, which is our option 2. Let us compare the given system of equations with a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. So that we can write a1 is equal to 4, b1 is equal to 6 and c1 is equal to 5 and a2 is equal to 8, b2 is equal to 12 and c2 is equal to 10. So from here we can say a1 by a2 4 upon 8, which is equal to 1 by 2, and b1 upon b2 is equal to 6 upon 12, which is again 1 by 2, and c1 upon c2 is equal to 5 by 10, which is again 1 by 2. So here a1 by a2 is equal to b1 by b2 is equal to c1 by c2, so which is a condition for infinitely many solutions. So we can go with an option 2. The given system of equations has infinitely many solutions. Given a vector A is equal to I cap plus 2j cap plus k cap and vector B is equal to I cap minus j cap plus 4k cap and vector C is equal to I cap plus j cap plus k cap, such that A plus lambda B, vector A plus lambda times of vector B is perpendicular to vector C, so that we can say the dot product is 0. So that is A dot C plus lambda times of B dot C is equal to 0. Let's find A dot C vector here. A dot C vector is equal to 1 ones are 1 plus 2 into 1 2 plus 1 into 1 1, which is 4. So this is 4 plus lambda times of, and B dot C we can write 1 into 1 is 1, minus 1 into plus 1 is minus 1, plus 4 into plus 1 is plus 4, so which is equal to 4. So 4 plus 4 lambda is equal to 0, 4 taken common, 1 plus lambda is equal to 0. So 1 plus lambda is equal to 0 since 4 cannot be equal to 0. So lambda is equal to minus 1. So we can go with an option 3. The value of lambda is minus 1. Given modulus of a vector A is equal to 10 and modulus of vector B is equal to 2 and dot product of the two vectors is given is 2, is 12, sorry, and let us consider theta be the angle between the two vectors A and B. So we have A dot B is mod A to mod B, cos theta is equal to 12, and mod A is 10 into 2 into cos theta is equal to 12, or cos theta is equal to 12 divided by 10 into 2. So here we can write 2 6 times and again 2 3 times, 2 5 times. So cos theta is equal to 3 by 5. When cos theta is equal to 3 by 5, adjacent by hypotenuse, so opposite will be 4. So sin theta I can take it as, or mod sin theta we can take it as 4 by 5. Now let us consider mod of A cross B, which is equal to mod A into mod B into mod of sine of the angle theta. So mod A value is 10 and mod B is 2 and mod of sine theta is 4 by 5. So here we can say 4, 5 2 times, 4 2s are 8, 8 2s are 16. So mod of A cross B is equal to 16, which is our option 4. Given in the statement 1, either the mod of vector A is 0 or mod of vector B is 0. Then if we consider the dot product and if theta is the angle between them, then we can write mod A mod B cos of the angle between them. If either A is 0 or B is 0, we can say that mod A into mod B will be 0. Then we can write A dot B, which is equal to 0 into cos theta, which is 0. So we can say that the statement 1 is true. And coming to the second statement, A cross B is equal to vector 0. We can say that again if theta is angle between the two vectors, A cross B we can write it as mod A into mod B into sine of the angle between the two vectors A and B into n cap. And this A cross B will be 0. A cross B will be equal to 0 only when theta is equal to integral multiples of pi, that is sin theta is equal to 0, which means that vector A and B must be parallel. They should not be perpendicular. If A is perpendicular to B, dot product should be equal to 0, not cross product. So A cross B is 0, then A is parallel to B, we can say. So this is the second statement is false. So we can go with an option true and false. Option 1. If a line makes an angle alpha with x-axis and beta with y-axis and gamma with the z-axis, then we have cos square alpha, cos square beta plus cos square gamma. Their sum is equal to 1. So where alpha, beta and gamma are the directional angles of a line. So here alpha is equal to 90 degrees with respect to x-axis and beta is equal to 60 degrees and gamma is equal to theta with respect to z-axis. Then we have cos square 90 degrees plus cos square 60 degrees plus cos square theta must be equal to, the sum should be equal to 1. So cos 90 is 0 and cos 60 value is 1 by 2. So we can write 1 by 2 whole square. So cos square theta is equal to 1. So cos square theta is equal to 1 minus 1 by 2 whole square is 1 by 4. So we can write cos square theta is equal to 3 by 4, or we can write cos theta is equal to root 3 by 2. So we can consider plus or minus root 3 by 2. But here theta is an acute angle. So we consider cos theta is root 3 by 2. Since theta is an acute. So cos theta is acute, root 3 by 2, we will get it cos 30 degrees. That is pi by 6. So therefore theta is equal to pi by 6, which is our first option. We need to find the equation of a line passing through the point 0, 1, 2 and which is perpendicular to the line x minus 1 upon 2 is equal to y plus 1 upon 3 is equal to z minus 1 upon minus 2, which is passing through the point. So we can say x minus 1 upon 2, y minus of minus 1 divided by 3 and z minus 1 divided by minus 2. So we can say the point as 1, minus 1 and 1. Let us consider this point is A. And having the direction ratios of this line, the perpendicular line is 2, 3, minus 2. Let us consider a general point on the line by taking is equal to lambda. So we can write 2 lambda plus 1, 3 lambda plus 1 minus 2 lambda plus 1. So let us consider this is the general point here. Say this is Q. Now the direction ratios of PQ, of the line joining the 2 points PQ, can be given as 2 lambda plus 1, 3 lambda plus 1 minus 1, minus 2 lambda plus 1 minus 2, which is equal to 2 lambda plus 1, 3 lambda and minus 2 lambda minus 1. And since PQ and the line AQ is perpendicular, AQ is perpendicular to PQ, so that we can say if A1, B1, C1 and A2, B2, C2 are the direction ratios of two perpendicular lines, we have the relation A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Say this is A1, B1, C1 and say this is A2, B2, C2. So then we have 2 lambda plus 1, 2 times of 2 lambda plus 1 plus 3 times of 3 lambda minus 2 times of minus 2 lambda minus 1 is equal to 0. So we can simplify and write 4 lambda plus 2 plus 9 lambda plus 4 lambda and again plus 2 is equal to 0. So 13 plus 4 17 lambda and again here plus 4 is equal to 0. So we can say lambda value is minus 4 by 17. So that we can say the point here, this is 2 into, or the direction ratios, let us substitute here PQ, 2 into minus 4 by 17 plus 1, which is equal to 17 minus 8, 9 by 17, and 3 times minus 4 by 17, that is minus 12 by 17, and again minus 2 times minus 4 by 17 minus 1, which is equal to 8 minus 17, that is minus 9 by 17. So we can say the equation of the line passing through the point 0, 1, 2 can be given by x minus 0 divided by the direction ratios 9 upon 17, which is equal to y minus 1 divided by minus 12 upon 17, which is equal to z minus 2 divided by minus 9 by 17. So here in the denominator 17 gets cancelled, and also with the 3 table 3 3 times, 3 4 times, and again 3 3 times. So we can write x upon 3 is equal to y minus 1 upon negative 4 is equal to z minus 2 upon negative 3, or this can also be written as x upon negative 3 is equal to y minus 1 upon 4 is equal to z minus 2 upon negative 3 by taking minus common. So we can say the option 2. So option 2 is the answer. A line passes through minus 1 comma 3. Say this point is P minus 1 comma minus 3, and which is perpendicular to the line x plus 6y is equal to 5, and we know that if a line equation is having ax plus by plus c is equal to 0 and its slope is given by minus a divided by b, so we can say the slope of this line x plus 6y, say m1, is equal to minus 1 divided by 6. And since this line is perpendicular to the given required line, that is PQ, say PQ, say the slope of the line PQ is m2, then we have m1 m2 is equal to minus 1 since they are perpendicular. So we can write m2 is equal to minus 1 divided by m1, that is 6. So slope of this line PQ is 6. And passing through the point minus 1 comma 3, by using the point slope form, we can say y minus y1 is equal to m times of x minus x1. So passing through the point x1 y1, that is minus 1 comma minus 3, so we can write y minus of minus 3, that is plus 3, is equal to 6 times of x minus of minus 1, that is plus 1. Since we need the x intercept, so we need to put y is equal to 0 to get x intercept, because we need a point on the x axis. So we can write 0 plus 3 is equal to 6 times of x plus 1, or we can write x plus 1 is equal to 3 upon 6, that is 1 by 2. So x is equal to 1 by 2 minus 1, which is negative half. Therefore x-intercept is minus 1 by 2, which is our option 2, second option.